here on time. I was not here on time.
Thank you for coming and attending this event.
It looks so nice.
Oh, thank you.
Wow.
I've made an effort. I'm very cold though.
Very
See,
cold?
you've got a nice jacket.
Yeah.
No, I don't.
You can mind if you
I forgot my jacket. Welcome everyone. I'll do an acknowledgement of the country. I'd like to begin by acknowledging the traditional owners of the land on which we meet today. I would also like to pay my respects to elders past, present and emerging. Welcome again to a, I don't know, bi-monthly meetup now. It's accidentally bi-monthly, but that's okay. It just means we have to find less speakers. So if anyone wants to speak, please come and see us afterwards.
As a bonus, you get a very nice stand from these slides on stage.
That's right.
Yeah, you worked it as well.
If you want to get a
Not in
stand,
your answer.
we may have to turn it just a little bit.
I don't remember these lights
They
previously.
are amazing, but I feel like I'm seeing like double now.
You know that,
Wow.
right?
Yeah. Just, thank you. Sorry, the lights are amazing, but yeah.
Do we have, so there was a few first time sign-ups. Has anyone been here for the first time?
Yeah.
Yes, awesome, nice, excellent. You guys like new faces.
Wow. You're all amazing.
That's right. Yeah, so we're here to see a couple of great speakers. So I guess without further ado, we'll introduce Lovee Jain. She is going to talk about CloudFront active global infrastructure with latency-based routing. So she's from Prezzee, and she's a GDG Melbourne meetup organizer. That's Google Cloud. We'd love Google Cloud speakers too, by the way. We'd love speakers that don't talk about AWS. That would be great.
Not necessarily.
We need to mix it. We need to.
Everybody's welcome. Everybody's welcome. Everybody's welcome.
What I'm trying to say is that
Everybody's welcome.
we like to have our diverse speakers. Diverse clouds.
Except for Oracle Cloud.
Except-
Even Oracle Cloud.
Even Oracle Cloud.
Even Oracle Cloud. Maybe. Has anyone actually ever done Oracle Cloud?
Oh,
Really?
no.
Would you have to do a talk next month?
Tell us what it is.
Yeah, tell us about the Oracle Cloud, serverless on.
We've got a good free tier, I believe.
They don't have to talk, they're making money somewhere else.
I've done IBM Cloud.
Wow,
Yeah, I know.
you're still alive.
Cool. All right. So over to you, Lovee. Yes, welcome.
Well, if you had given me some more time, I would have dared you to say the title of the talk again without seeing the phone.
Oh,
No.
no. Infrastructure.
So, okay. So good. I thought you would see my ugly desktop. Oh, okay. Hello, everyone. I am Lovee Jain, and I'm a senior software engineer at Prezzee, a Women Tech Makers Ambassador, and also Google Developers Group Melbourne organizer. And tonight I'm going to talk about setting up CloudFront for active global architecture with latency-based routing. Now, before I start, I'd like to gauge the audience here, and I'd like to know how many of you here have heard of all the three terms highlighted in green. If you have heard of all the three terms, raise your hands like this. If only two, like this, and if only one, like this. Don't raise your hand. Wow, well, that's actually a very good mix here. So let's actually get started. So we'll actually look at these highlights. Yes.
Can I ask you why are you doing this? Like, what is the reason you're presenting this?
So maybe you should listen to the talk and you may get the reason.
Cool. Okay.
Okay, So we'll be actually talking about different, the highlighted words, which are there, like active-active global architecture, latency-based routing, and we'll look at an example global service, and then get introduced to what is AWS CloudFront. We'll talk about some added benefits such as caching and WAF, solve the whole thing together, piece it all together, address any risks, and finally, we'll see the final service being ready. So what is active-active architecture? Active-active architecture refers to a configuration where multiple nodes, physical servers, or virtual instances are simultaneously active and operational. So if you see in this diagram, there are 3 nodes. All the 3 nodes can actually process requests and handle traffic independently. On the other hand, we have another configuration called as active-passive architecture. In an active-passive architecture, only a primary resource or a group of resources are available majority of the time, while there is a secondary resource or group of resources that are there on standby in case the primary ones become inactive. The main point of difference is, say, if there is an influx of traffic and too many requests are coming through, only the primary ones will be there to accept those requests. The standby one would still not receive any traffic. So it will only receive traffic when the primary one goes down. So you use this kind of architecture when you want to maintain redundancy and keep your system fault tolerant. But for tonight's talk, our focus is active-active. So let's get back to active-active. So say I have an order processing service. Now that would be deployed on all 3 nodes. And when the users, they send requests, these requests will be distributed across all the active nodes, promoting parallel processing. And if there is high traffic, you can add more nodes to this configuration, which helps in achieving scalability, resulting in accommodating this increased demand without compromising performance. And when the traffic decreases, it automatically scales down the resources. So you only pay for the resources that you use. This is how you get a fault-tolerant system with efficient utilization of resources. Now, let's talk about what is active-active global architecture. So when we talk about the global architecture, we take the concept of active-active beyond individual service. So if it was my order processing service deployed on 3 nodes, that along with the respective ALB, that would become my full stack. So this becomes one stack, and I deploy this stack in multiple regions, so that now each region becomes fully functional and independent active instance capable of serving requests globally. So for example, my instance can be deployed in Australia, US, and UK. Now this redundancy ensures that if, say, an entire region is experiencing an outage, your service can still be accessed through healthy regions. Now, obviously, you can achieve this global architecture by deploying the stack with the ALB together in multiple regions. But what you also need is something called as Route 53. Now, when the request will come from the user, it will be the Route 53 which will decide which region will serve the request. Before we dive deep, let's actually talk about what is Route 53. Route 53 is actually a highly available and scalable DNS web service, or domain name system web service. So as it says, so it can do actually 3 things. As it says, it can register domain names, obviously, and then it can route internet traffic to your resources for your domain. And then it can also check the health of your resources. What we are interested in is how it would do that routing. So there are multiple routing policies that are supported. First, Simple. So you just tell it where you want to route your traffic to. That's simple. Then there is failover. Failover is the equivalent of your active-passive architecture. So in a failover routing, you decide a primary resource and your secondary resource. And your and the traffic will go to the primary resource until it fails, and then it will go to the secondary resource. Next up is geolocation and latency. Now, I'm going to spend some time here because a lot of people get confused with geolocation-based routing and latency-based routing. With geolocation, as the name suggests, you use it when you want to route the traffic based on the location of your users. So we are in Australia and say, I have deployed the service in Australia, US, and UK. So my location is Australia, so the nearest one would be the Australian service. So that would be based on the location of the users. That is quite deterministic. Because it is deterministic, you can actually have location-based content in your services. However, in the latency-based routing, you route the traffic to the region that provides the best latency. Consider this, for example. You have your service deployed in Australia, US, and UK, and your customer is in Singapore. Now, the location-wise, they should be routed to Australian service. But say there's a lot of congestion there, and it's going to take really long to serve the request, then it will take to serve the request from UK instance. So in latency-based routing, it will actually route the traffic to UK instead. So it is a bit non-deterministic. You might want to be a little considerate when you have some applications that can go into race conditions. Anyway, next up is geoproximity. So in geoproximity routing, you actually use both the geographic location of your users and of your resources with an added benefit of a bias. You can actually choose which resources you want to route traffic more and which resources you want to route traffic less by specifying a value. Next up, we have IP-based routing. You just choose the number of IPs where you want, for which you want to route the traffic to. Next is multi-value answer. So you can choose up to 8 resources, and then it will pick up any of the ones randomly from those resources to route your traffic. Finally, we have weighted routing. You specify the weight. Higher the weight on the resource, more traffic that resource can get. Okay, it's quiz time. Okay, I have deployed a service in Australia, US, and UK. My customer is in South India, and they made a request. And their request was served from the UK instance. What do you think the routing I have set up? Anybody? Yes.
Geolocation.
No. Yes.
Latency-based.
Yeah. It's actually latency-based. It could be, but it's latency-based because that's what we're here for. Anyway, no, that's not the reason. The main reason being, so even though South India could be geolocation-wise more closer to Australian service, but maybe there was more congestion there. That's why it got routed to UK, and that's why it was served from UK. Anyway, it's time for some demo. So what I've done is I've actually created a CF demo service, CloudFront demo service tonight, and I've deployed it in AP Southeast 2, which is Sydney, US East 1, North Virginia, and EU Central 1, Frankfurt. And I've set up latency-based routing. Now, what I want you to notice is this little ALB dot in the front. That is like a subdomain there. Although my service name is CF demo, that is like a public URL, but I've still got some additional things in there. And we'll talk about it later. So before we talk about it, I'll actually open this link in a browser. So this is step 1. Okay, I have to do this. Okay. So it says hello from AP Southeast 2 because I'm in Australia and it's closer, no congestion maybe, so that works. Now what I'm going to do is I'm going to use a proxy to change my location, and I'm going to choose Poland or France and paste the URL again and go for it. And it says, hello from EU Central 1. So that makes sense. And then proxy, again, change the location to US and try again. And it says US East 1. So that works. That is our demo. That works, right? Now, what I'm going to do is we go back to slides and we talk about what is, Amazon CloudFront. Yeah, it's good. So what is Amazon CloudFront? It is nothing but a CDN. Well, a CDN, or a content delivery network, is a service that accelerates internet content delivery, whether it's static or dynamic content. And it does that by reducing the distance between the user and the content, or the server that is delivering the content. So if you look at the diagram, so these are basically the origin servers, these stacks that I have deployed, and they are in Australia, US, and UK. And my user is in India, and when they try to access my service, they go to Australian service, and they get the request and content. So this whole round trip, maybe it takes 170 milliseconds. That's a lot. But with CloudFront, what you get is these little stars. These little stars are basically your multiple content delivery endpoints that are there across the world. And there is one here in India. So now, instead of going all the way to Australia, it can just call that edge. It can just reach to that edge and then request the content. If the content exists, it might now just take 20 milliseconds. That's a huge gap, isn't it? So it can just now take 20 milliseconds. And say, if there is no content, it will go back to the origin server, get the content, cache it, and then when the next request comes in, it can serve it from that cache. So this way, not only you reduce the latency, but what you also reduce is the load to your origin servers. Because instead of having each call to the origin server, now it can make calls to the endpoints, these edge endpoints, and get the data. So coming on to some of the benefits of Amazon CloudFront, which is reduced latency and reduced load on the origin service. Also, now for my example, I'm going to use AWS Origin, but you can bring in your custom origin. It also has DDoS protection with AWS Shield standard. You can even pay extra and get AWS Shield Advanced, and it has more features. Next, you get WAF integration, which helps in application level protection. You can have custom caching policies, and it is compliant to security standards such as HIPAA, GDPR, etc., and offers secure communication through TLS. Finally, you can actually deploy Lambda at edge. So you basically can run some complex business logic closer to your customer and provide some personalized content. And this, because it's running on the edge, it scales independently to your actual application. So what we are going to see is the example of WAF, caching, and Lambda at edge tonight. So it's time to piece it all together and solve the puzzle. Drum rolls. No, never mind.
Oh, that's pretty good. You could have
Okay, so that's the solution. So what we do is we just add the CloudFront there. So now what is happening is earlier we had that ALB in front of the whole actual URL. That would become the internal URL, and it will act as the origin for the CloudFront, while the alternate domain could be set to the public URL, and then you can attach WAF in front of the public URL. So what you get is all things all together lined up. So now what we are going to see is we are going to check whether this new URL or the public facing URL is also latency based or not. So let's actually have a look. I'll copy this URL in this browser, and we'll see. Okay. So that is also saying AP Southeast 2. I'm in Australia. Works. Proxying it again, changing the location. And it's Europe, so EU Central 1. And then proxy it again and change it to US East. Oh, sorry, United States, not US East. And there you go. So that works. Okay. The next thing we were talking about is custom caching policies. Now, what you can do is you can add caching policies on your CloudFront. Now, what you can do is say you have 10 paths. You can add 10 different policies. You can select one policy and just add it. Or you can actually set cache headers in the response coming from your application. And that would allow setting custom caching in your responses. So consider this for an example. We at Prezzee, we sell gift cards, right? So say we have an endpoint which is for all the cards that we sell. Now that is something we would like to cache, but checking the balance of the card, we can't cache that. We can't cache that because it changes. Similarly, we cannot cache order processing endpoint. So what I'm going to do is I'm going to show you how we can leverage caching. So can everybody see clearly this one? Everything?
Yeah.
Can everybody see the numbers clearly? Yeah. Okay. So I'm going to run this now. And it is just normal one. I have created another endpoint for caching. And I'm going to call this endpoint. And it says I'm cached for 30 seconds. What I want you to look at is the headers it is returning. So it has got the cache control header. It's coming from the response, and it says it's cached for 30 seconds. And it is a miss from CloudFront. And the latency was 147. Let me quickly run it again. Woo, hit from CloudFront. Look at the latency, 29 milliseconds. So that's right there, changing hit from CloudFront, 24 milliseconds. And refresh hit from CloudFront. And now this was 73 milliseconds because it was cached only for 30 seconds. So that one works with caching. The next thing we are going to look at is WAF. So let me go back to the browser. Now what I have got is I have set up two WAF rules. One is block by path, and the other one is rate limit. So if you do not specify the path that I have got, you would be blocked to access the application. That's what we want. So what I'm going to do is go back to Postman and add something random there. And when I run this, I get, woohoo, error. Lovee says 404 not found. Now this error is a customized error coming from CloudFront and not from the application. Let's have a look. If you look at these rules, they're there. There's also something called as logging and metrics. And you can actually see everything coming through in CloudWatch. So let's look at some of the logs. So there we go, 1 minute, you've got it here. And what you can see is it has blocked the request, and it blocked it with the rule block by path. What more you can see is what was the path that was given. Arguments are your query parameters, so you can redact anything that you like. You can redact headers, because sometimes you may be sending any secure data, customer data that you don't want to come up in your logs. So you can redact those fields, and then you can see all the method and everything and how it was blocked. So that is WAF in action. The next thing, the next rule I had on my WAF was rate limiting. Let's actually have a look at that one. So what I've got is, I have set up rate limiting that you can only call the endpoints 100 times in 2 minutes from one IP address. So let's actually hit that limit. So what I have done is, I'll actually change this to where am I? Oh. Okay, this works, and I'll save this. And what I'm going to do next is, I'm going to run this collection. Just this endpoint, and I'm going to run this for 100 times. Now that is running 100 times, and it's done. Nice. So if I now call this, it is working. What? Well, no. The thing is, it takes about a couple of seconds to realize that the rate limiting has been reached. So it's always there with WAF. So it will take a couple of minutes, but it will, yeah, it says 429 many requests. Lovee says too many requests. So you've got that error. But so if you want to look at the IP address is different, but somehow in my desktop Postman version, I get a different IP. So if I make this request now, it's working, but the Postman one is blocked. So it's blocked by IP after 100 requests for a particular path. So that's what we have got as demo. And let me actually show you the custom response bodies as well. So you can always create any custom response bodies you like. So I've created these, so you can actually create similar to what your application response. So your customer would not know it is directly coming from CloudFront or from the WAF straight away. So you can do that. All right, it's time to see one more thing. What is your good name, sir?
Jack.
Yeah, how do you spell it?
J-A.
Jack. Okay,
Yeah.
Jack. All right. All right, Jack. So let me do something. Let me just type in name and Jack. And oh, it's already blocked. My bad. I'll do it here. It's not blocked. Wait, did I get it right? I haven't checked it. Yeah. Well, I got it. I skipped the beat. There you go. It says, hello, Jack from Lambda Edge.
Thank you.
So now this is coming from the Lambda at Edge thing. It is not coming from the application. It is coming from the Lambda that is, so you can use, yes, so you can use it to basically give much more personalized responses. Okay, so it's time to go back to the slides. Oh, yes. Before we go to the next slide, I have a question. There's a big vulnerability in this diagram. Can someone point that out? Yes.
Can we hit the LB straight up?
Yes, that is correct. You're right. So even though this endpoint here, this is protected by WAF, this one out there has no protection. You can attack your application directly and take it all down. So what do we do? So, oh, hang on. So it worked. So what do? We have something called as prefix lists or called P lists. Now, prefix lists are the IP addresses used by various AWS offerings. So they're useful when you want to configure any security groups, network ACLs, or other network level controls within a VPC. So we have, if you look at the table, we have a prefix list for CloudFront as well, and it has a weight of 55. So let's actually implement this. So I'm going back to my service, and what is my point? Okay, we go to this. This is the ALB right here, and this is the security group for it. I go to the security group. So we basically add the prefix list as an inbound rule to the security group of the ALB. So I'm going to change this rule. So go to edit inbound rules. I'm going to delete it. Oh, before I do that, I should actually run the ALB.cf demo thing, if that is working or not. So I had a base URL. Oh, by the way, a very good one. So I've got at the root, I'm having hello world, but in my WAF, I actually only specified 2 parts. Where am I and cache me? So if I remove the ALB here, it's hard. And just call the CF demo thing, it would actually fail. Oh no, it's again, where am I? I want to remove where am I and call it. So it says 404 not found because I haven't got it, but the ALB one is still accessible, right? So the ALB one is still accessible. Let's keep it there. And now let's modify the inbound rule. I'm going to add a new rule, allow all traffic only when I have got something as CloudFront prefix. So if the traffic comes only from CloudFront, then only it is allowed. Otherwise, it's blocked. And now if I try to reach this one, it's blocked. It's still loading. I don't know if you can see that. Yeah, it's blocked. It won't show up. And that's how you actually protected that open endpoint that was out there. All right, coming back to the slides. So the other things you might want to be a little more cautious about is that when you're doing the active-active architecture, you want to be really thorough with your use case, right? What you want is you want to understand where your data would live, what kind of experiences you're going to give to your customers. What you want is you want to give them similar experience in all the different regions, right? And say you have siloed data. Now, why I'm talking about this is, say you have your data for Australian customers only in Australia, and all your Singapore customers also in Australia, and UK customers in UK, and US customers in UK. So your data is siloed. And what if with latency-based routing, which is not deterministic, it points you or requests or routes your requests to any other region? You won't be able to serve that request. So you might want to consider things like global tables, like DynamoDB or anything like that. I'm not promoting single table design, or I'm not talking about it. It's a separate topic. Then you want to maintain some data consistency, eventual or strong. And then you might want to be a bit more cautious with race conditions. Definitely take much more deterministic approach in that scenario. And then one of the biggest one, it is a lot of costs. It is very expensive because you would be running so many instances in so many regions. And it is not just the production environment. You need the same thing, the same setup in your dev, in your test, in your staging, the number of environments you have. So the cost can go up like really quick. The next one is increased efforts. Now, having such infrastructure, it takes a lot of maintenance. It takes a lot of developer time and a lot of efforts, especially when it comes to deployment. There could be a lot of deployment caveats. For example, with the name conventions, if you're trying to deploy a WAF, it needs to, if you're trying to deploy the log group for the WAF, it needs to start with AWS WAF logs. And then you need to be mindful that if you are doing a CloudFront, then the primary region is US East 1, and it would not accept any certificates from other regions. And then I don't want to get started on the IAM permissions. I hate them. Yep. Is this recorded? You better be. I want to let them know it's that bad.
I reckon the primary region in US East 1 is even worse than the IAM permission.
Yeah, well, if you don't like this design at all, we may have some alternatives for you. So the alternative is basically you can have in your ALBs, you can have integrations such as AWS Global Accelerator, especially I want to talk about because it can direct traffic over the AWS Global Network to static IP addresses that serve as fixed endpoints in the nearest region to client. So it is similar to what your CloudFront does, but here it just helps with routing, and those points are quite static. And then you can also have WAF at the ALB level, and the ALB also supports in-memory caching. So when you do this, you would have to do it, maybe if you're doing it in 3 ALBs, you have to duplicate it in all the 3 ALBs. And one of the scenarios could be, so for example, say you are serving, we created a BFF or a backend for frontend. So a backend for frontend can grab data not from one service, it can grab data from multiple services. And say one of the places that it grabs data is your S3. You won't be able to do it with just this setup, as in your service will have to be called to get to S3 instead. You won't be able to route it directly to the S3. But having a CloudFront, you can actually specify another origin for that same domain name with a different path. So that is one of the scenarios where you might actually choose CloudFront over this setup. It could vary as per your needs. So definitely do more research when you are selecting what you want to do. But finally, we have got the application that's deployed in 3 different regions with ALB routing, and we have prefix lists set up so the ALBs are protected. We have got a CloudFront with caching, with WAF and Lambda Edge. So that's our final solution. And so we have now learned about how we can reduce latency, high security, rate limiting, custom caching, reduce load on service, DDoS protection, firewall, and personalized edge response in one single app. So thank you. Thank you so much. And
any questions?
Very well done.
I've got one.
yes,
Do you use it in Prezzee?
yes, we have just deployed it.
Oh, really? And you're doing a database at the back end?
Yes, Dynamo.
Oh, Dynamite. Oh, that makes it easy.
Yeah.
It's probably a bit more complex with like RDS in Postgres.
Yeah.
That would be interesting.
That's why I don't promote it. It's a complex. People would fight. Yes.
What other options did you consider?
So, okay. First thing I want to clarify why we were doing this. We did this for our BFF. So we already had a service that's deployed internally with latency-based routing, and then our BFF has to be publicly available, and we want the latency to be really, really minimum. And that was the reason we were trying to look at multiple options. We tried, we had the ALB thing, but there was still, and we wanted the CloudFront, and then we also wanted caching, as I said, with the product list. We have APIs, so we wanted to reduce the caching, and we have it as global thing. And we also have some monolith, I would say, and that's running in multiple regions. So the routing had to be done at multiple levels. So the main concern was just latency thing, and we already had CloudFront in front of our monolith, and it's actually going from one CloudFront to another CloudFront at the moment. Yeah. And
So
then
effectively, the problem you were solving was speed.
yes,
Performance,
mostly
right?
performance. Yes. Yeah.
Yeah, no, I was just wondering, for example, there's CloudFront functions and sort of and at the edge. And
Oh,
there's obviously third-party
so-
options like Cloudflare. And,
Yes.
you know.
So we are AWS, so definitely made sense to use CloudFront. Lambda Edge, we haven't implemented the CloudFront function on Lambda Edge yet. We are still in that journey. This was just for example. Yeah. But it's still in consideration. But we are looking at Edge, to be honest. Yeah, there are multiple reasons we want. So I think you cannot access the body with CloudFront functions. Yeah, it has limitations. Yeah.
Well done.
Thank you. Any other
Okay,
questions?
thanks. Would you like to go forward to food there? Hopefully it's too warm. It's closed and
Oh, yeah.